Okay. Let's look at creating our own piecewise graph, um, and then evaluating a limit with this. Okay. So first things first, in terms of graphing piecewise functions, we did this way, way, way back in the beginning of the year. Um, for however many pieces that you have, my suggestion is that you plot points and then sort of look at the form of the function to kind of fill in what that would look like. Okay. Now, a little explanation on what these domains are. Okay. We're graphing this function for all values of x that are not 3. So if you did create a table of values from this, you could pick any numbers that you want besides 3 to plug into this function, right? Okay, so let's say we plugged in -1, and then we plug in 1, and then we plug in, let's do 4, because that's on the other side of 3. So if I plug -1 in, I get an output value of 9. If I plug in 1, I get 7. If I plug in 4, I get 4. Okay, so over 4 and up 4 to here. So obviously, filling in the rest of this, this is a line, right? This is a linear format of y equals mx plus b. So we have our slope and we have our y-intercept for that, right? So I'm going to, now the one thing is when x equals 3, we need to plot this point even though it's not in the domain of that function. So if I put 3 into this function, it would be 3, 5, right? However, when I go to 3, 5, which is right here, I'm going to put a hole in the graph because I'm not supposed to include where x is 3, right? So now this graph takes a little bit more of its shape. So we get something that looks like this. Okay, move my face out of the way here. So after that, we go to the second piece. And the second piece of this is simply saying when x is 3, the output is -3. So something like this, where they're only giving you one point in the domain of that piece, this is basically giving us the point 3, -3. So if we go over 3 and down 3, this is where that point exists. So again, this is what we call a removable discontinuity. There is a hole in the middle of this line, and the point exists down here at -3. Okay. Now we've done a couple of these already. Go back and look at some of the videos that preclude this. If I wanted to do the limit as x approaches that hole in the graph, okay. Now, I'm not going to keep showing these left and right hand limits. What I am going to do is just approach. As we approach an x value of 3 from the left, the y value appears to be approaching 5. As I approach an x value of 3 from the right side of this function, the y value appears to be approaching 5. Even though those arrows, those fingertips will never touch, they are converging on the same space. Right? We're not getting behavior like this. We're not getting behavior like this. We are seeing those points coming together. Even though they don't touch, they are approaching a value of 5. So the limit is 5. But again, do not confuse the limit with the actual value of the function at 3. This question is asking, what is the output at 3? Where is that point? And the point is at -3, even though the limit is approaching 5. So again, the value of the limit does not have to equal the value of the function. All right.